Assalamualaikum to my both panel. I hope both of you are in good health during this MCO. I am Nurarina Binti Amir. I would like to present my undergraduate project 1 about oil palm nutrient content using multispectral drawing. My project is covered by Dr. Abd Wahid bin Rasib. In this proposed defense, the slide content have introduction, literature review, methodology, preliminary result, and schedule. First of all, for introduction, oil palm is one of the major commodity crop which is mainly grown for the industrial production and acts as a great booster in promoting socio-economic development in Malaysia. The quantity and the quality of oil palm trees must be monitored accordingly for the industry to meet the requirement for oil palm trees and to maintain the sustainability of oil palm production. Oil palm requires sufficient nutrient in the right balance to produce good yield and to stay healthy in the long term. Furthermore, the main nutrients needed by oil palm are nitrogen, phosphorus, potassium, and magnesium. In order to assist farm manager and operators in day-to-day management decision, full and accurate information on oil palm condition is greatly needed. In the recent years, conventional method of manual monitoring in oil palm is no longer feasible due to development of remote sensing technology such as ground-based, airborne, and satellite that can be used as it saves the cost, time, and energy, and able to enhance the possibility of classifying the vegetation through spectral analysis. Next is problem statement. There are three problem statements that I would focus on. The first one is conventional method in analysis require a lot of time in obtaining the nutrient content information. Conventionally, the nutrient content information is obtained through soil and oil palm leaf analysis, which involve destructive chemical analysis method as well as having an agronomist to determine the nutrient deficiency. And leaf analysis better describe the intake and demand of palm trees from Form 3, Form 9, and Form 17. However, it takes a very long time to obtain the result of chemical analysis, which is done through a series of laboratory steps. Second is unfamiliar with the application of new technologies in obtaining the information of the nutrient content. So they always use conventional method to manage the crop. And lastly, the farmers manage the crop and often use fertilization without having information on crop needs and soil composition. It is because lack of information, especially for nutrient content. Next is aim and objective. The aim of this research is produce nutrient mapping of oil palm using multispectral image and thermal image. And for objective, the first one is to analyze the spectral response curve for oil palm nutrient mapping using UAV platform. Second is to produce a map of oil palm nutrient based on multispectral and thermal image from UAV platform. And lastly is to analyze the extraction of oil palm nutrient information using UAV multispectral and thermal image. For research question, there are three questions, which is how to analyze the spectral response curve for oil palm nutrient, how to produce nutrient map using UAV multispectral image and thermal image, and how this extraction of oil palm can be analyzed. Next is significance of study. First, it will contribute the information of nutrient content of the oil palm that will help the farm managers and operators in day-to-day management decision. Full and accurate information on oil palm condition for proper growth and development. Second is related parties such as Malaysian Oil Palm Board, MPOB, can use the result of this analysis for future references to enhance the oil palm industry in Malaysia. Next is for scope in this study. The study area is Bukit Keledek Estate. They are near to the border of the state of Melaka and Negeri Sembilan. Bukit Keledek Estate is one of the estate from the trade wine plantation Berhad that located in Mukim Gemenceh, Tampin District, Negeri Sembilan, Malaysia. There are 6 instruments that were used in this study, which are DJI Phantom 4 drone, Survey 3W multi camera, DJI Zenmuse XT thermal camera, Spectral Evolution RS 3500 series field portable spectral radiometer, GPS Topcon tripod, and lastly, Toughbook. So for software, there are 5 software that were used to process the data, which is Pix4D, ArcGIS, AutoCAD, Argisoft Photoscan, and NV. So next is literature review. Based on the reading, I can know that the oil palm is monocotyledon and the crop produce 2 types of oil. Fleshy mesocarp produce palm oil, which is primarily used for its edible properties, and palm kernel oil is provided by the kernel and is commonly used in the oleochemical industry. Oil palm is the highest producer of dry matter in Malaysia, therefore it requires a large amount of macro and micronutrients for growth and yields. Nitrogen, phosphorus, potassium, and magnesium are the most important nutrients to sustain growth and yield of oil palm. Plant nutrient management is a key aspect of profitable oil palm production, and significant advances have been made over the last few decades in understanding the nutrient requirement of this group. So visible and near-infrared spectral remote sensing observation can provide information on the content of leaf chlorophyll, and such information allows early detection of plant nutrient deficiency. So the potential of UAV is enormous because it provides a self-operated imaging tool capable of providing frequent and timely monitoring of oil palm plantation. Compact multispectral drone sensor capture high-resolution image in the visible and near-infrared electromagnetic spectrum, enabling the calculation of vegetation indices such as NDVI for productivity estimate and vegetation classification. The multispectral camera, which can acquire a limited number of spectral bands at once in the visible until near-infrared region, are widely used to assess green biomass, nutrient status, pigment degradation, and photosynthetic efficiency. So spectral radiometer that has wavelength from 350 and 2500 millimeter, which provide a uniform visible near infrared and short wave infrared, was used to obtain the reflected data of oil palm leaflets to determine their nutrient levels. The spectral reflectance from oil palm leaf and the amount of nutrient obtained from the Fourier analysis were examined and analyzed, and then evaluation of the relationship between these 2 variables were made. So remote sensing using a thermal camera can be an important source of data to understand the transpiration process, and the workflow of thermal images processing are similar to RGB data. By produce the nutrient mapping, it can show that the study area that is classified as deficiency class and required to improve the implementation of fertilization and management practice. Next, proceed to methodology. In methodology, there are 5 phases, which is phase 1, data acquisition, phase 2, pre-processing, phase 3, processing, phase 4, analysis, and phase 5, final output. For data acquisition, there are 2 parts involved, which are drone-based multispectral image data and fieldwork data. So it is done by using UAV to collect the aerial image for RGB, near infrared, and thermal. The aerial image were taken using Phantom 4 will be attached with the camera, where the top of the camera should be facing forward. Meanwhile, the first step in the fieldwork data collection is to collect spectral reflectance curve by using EVO spectral radiometer. The spectral radiometer data collection for 25 samples of oil palm trees are using the center of the front 17 of the leaf because that part has contained most nutrient in oil palm trees. Next is topographic survey. So it is a surveying quality global positioning GPS that are used to determine the location of features shown in the study area. Lastly, GPS observation also is carried out in the selected area to obtain the ground control point (GCP) with coordinate references by using TopCon GR5. The result of the control point will be used to execute the correction in layer stitching and layer stacking process. Next is pre-processing. In data pre-processing phase, there are several processes that need to be performed. There are layer stitching, layer stacking, orthophoto, geometric correction, radiometric correction, which is involve the conversion to reflectance, and topography, DSM, DTM, and lastly, thermal image. So for layer stitching or mosaicing process, is needed to get the result of orthophoto image from the UAV data. So the process is a technique for tiling the digital image for image processing so that an orthophoto image can be obtained. So this process is performed by using PITS for the software for the data. So after the previous step of layer stitching is complete, the layer stacking process will be carried out for combining the multiple image, which is RGB and near infrared image into a single image to segregate the each pen for each image to collect their digital number by using ArcGIS software. So in this study, orthophoto has been produced and overlaid with other orthophoto after undergoing the procedure of image stitching and the procedure of layer stacking. So after that, the geometric correction needs to be performed for all the orthophotos that have been generated from UAV image in order to correcting the geometric distortion from a distort image. So this process is performed by using NV software. So for conversion to reflectant, must be performed to correcting the data for sensor irregularities and to convert the data to represent the reflected or emitted radiation measured by a sensor accurately by using the formula above. So next is digital terrain model or digital surface model is produced during the processing step 3, which is DSM, automosaic, and index in PIX 4D. So once the raster DSM is generated, the tile of raster DSM are merged. Lastly is the thermal image. So it is a potential tool for estimating plant temperature, which can be used as an indicator of stomata closure and water deficit stress. So the temperature of each pixel was first calculated from the 8-bit grayscale image by using the equation below. So next is the processing phase. In this phase, the reflectant graph for UAV and spectral radiometer were derived from the spectral reflectant of the selected oil palm trees. For this study, the data processing is conducted to extricate the estimation of normalized different vegetation index, NDVI, and soil adjusted vegetation index survey maps were imprecise by using near infrared and red spectrum. So these maps were produced for performing the analysis of the oil palm trees in the study area by using the following equation. So next is modeling foliage. By using the foliage data, it will divide into two sets, which is set A is treated as a reference from which the estimated value for value of nutrient for set B will be calculated. So regression analysis will perform to the data in set A to see the relationship between the nutrient element with one or more band. So equation with the highest R2 value is selected to use in the calculation. Then the calculation will proceed to solve the value of Y for each nutrient for set B. Lastly, RMSE value for each nutrient element will calculate using the chi-square test. So for analysis, it will divide into two-part analysis, which is quantitative analysis and qualitative analysis. For quantitative analysis, it will analyze the t-test and RMSE calculation. So meanwhile, for qualitative analysis, it will be analyzed in terms of the result between foliage concentration, vegetation index, and thermal image. Next is the expected result. So the final output of this study is oil palm nutrient map that need to show that will show which area have really good content of nutrient and the nutrient distribution at the study area. So and for preliminary results, there are contour, DSM, and 3D view that have been processed by using ArcGIS and ArcSym. Well, this is the preliminary result for RGB, near infrared and thermal orthophoto that have been processed by using Pix4D and ArcGIS photo scan. So lastly, this is the preliminary result for spectroradiometer reflectance graph by using Excel. So next, this is the schedule in accomplishing this proposal for undergraduate project 1. So it is being started since October until now in January. So that's all from me. Thank you.